All right, Mason, sorry about the sound on the last one. So this recording is for you. And so all we're doing in this lesson is reviewing adding of like terms and then adding that to our equations. All right, so let's talk about adding like terms. All right, hopefully you remember to add like terms, you have to add their coefficients. C-O-E-F-F-I-C-I-E-N-T-S, right? You got to add their coefficients. Okay, so let's take a look at these couple examples. If you remember on this one, we have 3 of them plus 5 of them gives us now 8 of them. 8 of them and 8 more of them gives us 16 of them. And what are the thems? The x's, right? The like terms. All right, so we simply just added up like terms. Okay, so what would you get on B? When you add these like terms, what would you get here on B? Give you a second to think. All right, and hopefully this is what you're thinking. 10 positives and 17 negatives leaves me 7 negatives of them, right? So a negative 7y. We're just adding like terms. All right, how about C? What would you get on C? All right, so hopefully as you work your way through, you say 3 of them minus 5 of them gives you a negative 2 of them, and a negative 2 of them and 1 more negative gives you a negative 3 of them, right? So we end up with a negative 3n. All right, all review, right? We've done adding like terms before, no big deal there. Okay, so number 2. I found through my teaching that students were trying to simplify things on different sides of the equal sign. So this first one, number 2, says you can only simplify quantities on the same side of the equal sign. On the same side of the equal sign. Now don't write this next part in your notes. I just want to illustrate for you. So, hate when it does that. So when I draw a dividing line right here at my equal sign, right? I have a left side and right side. I can add up like terms on this side, and if there were any on that side, there's only a number there. Okay, look at the second example, same thing, right? See, I can add up those like terms there, and I can add up any like terms on this side, but I can't add something on this side with something on that side, right? That's moving of the quantities. So I've just found over the years of teaching that some students were trying to add stuff on the other side, and you can't do that. So when you add like terms, it's always on the same side. Okay, so let's take a look at this first example. And our first thought would be, let's add up our x's. 5 positives of them and 8 negatives of them leaves us 3 negatives of them. All right, so at this point, Mason, everybody, now we're left with quantities added to the variable. All right, here's our variable. And you can see that the positive 3 is added to the variable, and the negative 3 is multiplied times the variable. And of course, we learn whenever quantities are both added to and multiplied times the variable, move things added first, right? So we're going to add the opposite of a positive 3 to both sides. All right, we end up with negative 3x equals 6. And now to move that negative 3, we'll do our shortcut. We'll divide both sides by a negative 3. Negative 3's divide out. We've isolated our variable, and we get x equals negative 2. And just like always, as you have time at the end, you can go back and put that negative 2 in the original for the variable and see if indeed you get the same answer. Okay, so the right B here, same concept, just a little bit more involved. And so you're going to add up like terms on the left, add up like terms on the right, and then it's boiled down to moving things added, moving things multiplied. If you'd like to try it yourself, pause the video, and you can see how you do. All right, so looking at this, I can add 7 negatives and 5 more negatives and get 12 negatives. And then on this side, I can add a negative 1n and a positive 7n and get a negative 6n. Oops, and that's a negative 8. That's a negative 6n, right? And we have a negative 8. So just be careful there. And it's a positive 6n. Wow. Okay. Brain flipped on me. Ah, interesting. All right. So 1 negative n, 7 positives, right? Would have given me 6 positive n's. I don't need that plus sign, and then a minus 8. And you could have written it -8 plus 6n as well. You can change the order, right? Commutative property. So at this point, just moving things added, moving things multiplied. So we'll add a +8 to both sides. We get a -4 equals a 6n. Shortcut, right? Isolate that variable, divide the right by 6, divide the left by 6, and surely you can reduce that fraction quite easily, and we get a -2/3, right? -2/3. Okay, so, once we take care of adding like terms, you can see then we're just down to doing the things that we've done. All right, so I got two more examples here. Two more examples. All right, so again, C, my advice is why don't you pause the video and go ahead and try C and then turn it back on. All right, so looking at C, hopefully you thought about minus a minus is a plus. Now I can go about adding those like terms. 4 of the y's and 2 more of the y's is 6 of the y's. I can then add my numbers. A +3 and a -8 is a -5. And on the right, I can do 10 positives and 13 negatives and get 3 negatives, right? And see now how you're right down to moving things added, then moving things multiplied. Let's add a -5 to a +5 to both sides. And we now have 6y equals 2. Divide both sides by 6. And we're going to end up here at y equals 1/3. Y equals 1/3. All right, that's the idea and that's the concept. Pretty simplistic. All right, now D, you can have two thoughts to D. You could think that D is the special case, and you can solve it that way. And you would think that D is the special case because we have a quantity in the numerator above a fraction. The difference here is, can we add a 2n and a 3n? And the answer is yes. So because of this situation, we don't have to treat it like the special case. Now you can. You can do this problem either way. I'm going to show you both ways. But the way I would do it is, I would first add the like terms. So 2n and 3n is 5n. That's over the 4 equals the -6. And now you can see all we need to do is multiply both sides by the reciprocal, right? Multiply the left by 4/5 to isolate the variable. Multiply the right by 4/5 to isolate the variable. We end up with n equals -24/5. And there's our answer. Now you might say, well, what would have happened if I treated it as if it were the special case? All right, well, let me show you. 2n plus 3n over 4 equals -6. All right, special case. Multiply the left by 4, multiply the right by 4, right? And these 4s divide out there. Next line would read 2n plus 3n equals -24. 5n equals -24. And look what happens now when you divide both sides by 5. Sure enough, you get the same answer, and you would have to write n equals -24/5. Okay, so that one was different because we could add the like terms in the numerator. If you can't, then you got to treat it as the special case. Hey, look, that's the idea right now. So now we've added adding like terms to solving our equations. So you're going to look to do some simplifying, and then you're simply going to do what we've learned. When quantities are both added to and multiplied times a variable, move quantities added first. How do you do that? Add their opposite to both sides. And then how do you move quantities multiplied times a variable? You move them by multiplying both sides by the reciprocal, or do the shortcut. If it's an integer, divide both sides by that integer. Hey, that's the idea. That's the concept. It's that easy. And so hopefully you'll get good at it. All right, that's the lesson.